I'm Steve Tsikas. If you want to get access to the 20-meter telescope, then the person you contact, for those of you in the audience that don't have access here, I wrote some sign-up forms. For those of you who are online, just email me. My email address is the last page of this digital PowerPoint slide. I do this presentation every year. All you notice this year, I'm actually in one of the presentations to us at 3 o'clock. Normally, I give this talk after dinner, getting along for a couple hours or more. We open the telescope, which is right outside this building. Designed and a presentations. Invite to conduct this demo a little bit differently for the benefit of those who are online. I'm going to do these project topping first. And if we have time, we'll see the presentation that actually make us move. Not we can you do them. Every year, when I get a new subject topic for the 20-meter, I'm still learning how to use it all these years. Every year I'll have to think about what else do the 20-meter bring a telescope here. And this year, profiles. They were also the mode of the 20-meter telescope already. Or look at telescopes, the Pulsar is a pulse and had an interval. You can see that pulse speed change depending on what Pulsar is. That's a symbol. But actually, protocols do be very complicated. And you can see some of those more complicated on sweet one. So this is the agenda. There's heredity slides, not going to bore and deeper roles. Those slides are really around this. But I will focus on parts of this presentation. What's listed in there, the intervals are the easiest to see where just going to. Give some examples of those. When I start out with the use thermal every year, frequently it is the sort of or creating my own observations is to see if there's anything on the 20-meter side already in there. Because it usually is a lot. So if you have those, I look at what's there. 2, 3 new observations. There's a list series of different presentations on the 20 meters. Outline optical astronomy, where you've got great organization like the Astronomical League, as always, makes it very colors who don't really see stars. And so I started intellectual here on the SARA analytical page. You tour the SARA sections tomorrow. If you haven't seen the original Pulsar presentation from 2020, that's there. That is based in part on the I'm just searching for it. I call that very good. It explains all the different that you see the result presentations also. If this was in the evening slot, be going into the demo now. It's very easy to input data, very easy to get results, but the interpretations is the part. So you skip on it. Because we are talking about pulsars, there's a couple of numbers here I want you to keep in mind. There's something called integration time. So these instructions are model 20-meter web storage. Was a public instructions as well as the database of all the observations, whether the pulsars or other observation methods accessible. 20-meter side. But for pulsars, it's important to set the integration time to 1/30 of the year. I've seen a lot of other ends that suggest one will here, but you gotta remember that 30th, 100, somewhere in that range.
Yeah.
And here's the results of the 20, if you Pulsar, you'll see what's called a Presto Fretfold Plus. In the 2020 presentation for Pulsars, it explains what each of those panels do. The one in the upper left is the one we're interested in because it gives a hostile of a limited Pulsar. Pulses look like. You see this thing there, a regularly Pulsar. As far as the pulses. Here's a close-up of that. Some more recent demos. I've been focusing on this because if you did your radio strongly, one of the mistakes you could make is to think that the electromagnetic blade rays radiation comes into the dish as parallel lines deep focus. That's not exactly what it works. It's more of a beam counter. These are thinking those turns, you'll yield and turn results a lot better. So the beam is the area in which the radiation will be detected by the radio telescope. So you got that main lobe there. And that outline is a bit misleading. It's non-hearts. Because that line there is defined as E with a percent. With half maximum volume. That's fine. It's the rest. When you're doing radio, then it's the rest of the scans with the 20 meter beam is moving and forced to take the image. And sometimes it's roll our resolution. When I put it, you can actually see the beam trace. I think that's due to the antenna not being able to pull over fast enough as the usage from a source. There are no guides on this. See what interpretations was. So I really wanted to look at now the 20 meter. There's two receivers on it, but one receiver that's most of the time is 1.4 gigahertz, and the beam size is full for our use. So that's the resolution. Anything within there, that's a source, radio source, is going to be spread, and that needs to something not unusual fast. That is the message. Next couple of slides, I'm over here. This next slide here, get into interpulses, but even the one I'll put out a little more. A lot of theories on how the pulses are. It might be more of the root. Mechanism, so you rewrite neighbors to a lot of theories of causing them, and different authors. We will try to focus on one or the other. The simplest type is explanation is where you have the magnetic and rotational axis close to 90 degrees. So one interpretation is the main pulse is from one pole and the interpulse is from the opposite pole. Let's not as technical as the main pulse. I mean, something around it can get even more complicated because there's pulsars that are called some pulsars. And some of the papers get into elaborate theories with patchy cone theories of how they intersect with rotation things. Not going to get into that, but keep next couple of slides. All over that's more for your reference. And here's our who we start focusing. So you may have seen on TV a commercial because that commercial has been years on TV and it's been on several channels. And many use that trying to bring something into there's one thing I want you to learn here. So there's the Colonial Penn Life Insurance Company commercial. And there was a gentleman that comes out, Jonathan Moss, tells everybody, remember the 3 Ps of life insurance. What are the 3 Ps? Well, it's all price, it's price, price. So now I'm going to help. So when it comes to pulsar profile observations, there are also 3 Ps. And those 3 Ps are parameter for the frequency, a parameter for the iteration time, and a parameter for the observation time. So you know those 3 parameters, which will be you can get the best out of your pulsar profile observation, your meter, when you comparisons. So the first parameter is the filter. When you go to the 20 meter, you're going to select the field. You get expresses. And it says about right. You can have the whole range, the elevated filter. Then you have a hydrogen one. One of the hydrox. You use it on one. OH1 oxygen. So you use the speed was more frequencies will generally mean you're going to have better profiles. When you have iteration time, I've got a more official definition of that here, which you can read. But maybe some simple terms, if you want to think about it, it's at least this is the way I did it. It was sort of a processing time, the data from these. And what happens here is, and that's why we need to know how to set the integration time for your pulsar. 1.3 or 1. It's the integration time is much longer than the pulsar period. Then you're going to see a lot of pulses like on the left. If it's too short, it's going to be more noisy. More noisy. If it's just right, you see something. And in the last rule, remember the observation time, that's pretty easy. You can imagine the longer you observe something, the more they a sharper observation. Oh, yes. Types. So there are a few types of pulsars. I went on the internet and looked at some professional papers to see what might be a very real possibility for the impulse pulsars is the easiest. The double pulsar, one example is essentially need device and got 2 pulsars rotating around and show it just like a normal star. You have also mode switching pulsars where they're switching patterns in their profiles and very complicated. The other things I listed here, just to be aware of, those have been presentations. And you want to see some pass. Let's keep those in mind. So let's start off in all of its intervals. Well, I had to first find out where are the intervals pulsars. So from about 3 papers, I extracted these name charts that list them. And you're going to see some arrows pointing to pulsars. That's because I took all these charts and then mashed them up to in the 20-meter database. I didn't have to observe these all over again. I told it was out there. Well, it was a good observation from that observation. And in the 20-meter database, there's a variety of quality. You have some made by professional scientists quality, and you also have a lot made by sitting switch. The first testing. So these are the ones. Period. It's another chart. Period. Let's go with first. The few things I want to read, or we do some examples. So most pulsars don't have easy to remember names like the kernels. In the 20 meter, the pulsar names are usually PSR followed by the right position that's termination. And you see that. Yeah. Well, that arrow gives you the pull. And for the crowd pulsar, I know really that the interpulse is basically right in the center of the pulses. Pretty sure this is the interpulse. The thing to remember is you have your information up here. The sample time is the integration time, so it's here. The duration or observation time is here. And the filter is up here. See it up there. And to keep in mind that pulsars, like everything else, move around and stuff. You have coordinating systems from 1950, which are designated by a B in front. The coordinate systems designated by GJ, which is 2000. And so in the crowd nebula moving over 50 years, it's kind of shiftable. Now we're into 25 years, get to the next quarterly systems up. I believe we'll have Agni, the radio telescope, adjust for this because you have to be really focused on the setting. So that's why you may sometimes see these coordinates in the actual observation are a little different from time to time. The scale is making some adjustments. We'll split period here. Now, for this particular demo, I found a new database on Pulsar. Usually I'm coding the Australian database of pulsars, which is very useful for all of these. But for this particular type of pulsar profiles, the best I found out there was the European Pulsar net. Just actually have a professional diagrams results of pulsars. So you can compare the two. As one extra measure is finding out to actually pick up the intervals. So you can see here the main pulse. Now these pulsar profiles through the European Pulsar. Put some instruction down here for websites so you understand what these lines are, different colored colors. It's actually quite a simple chart. You can just see further down a lot of other things in there. So let's take a look at these 3 Ps. Pulsar profiles are, started off. The frequency range, 1300 to 1800. You get that up here. The sample time, which is the integration time, is down here. So we have the pulsar period up. Let's see the deep race right here. And then milliseconds here. What's the line time 100 or actually you can reach the range of what the 20 year can do. You can see and the observation. Every example we're going to do, we're going to have those 3 keys there and see how they compare. So we're still on the travels. A lot of observations in this space for this. We're looking at those. So I pointed out what I thought the interpulse was on these varying qualities. So between these two, got the 3 Ps down here. And obviously the one on the right is the pool. Let's see why. Well, the one on the right is got a larger frequency range. That's definitely not. And the one, and then the integration time, one on the right also has a better integration time. That's the lower limit here that you can see. So that's how. And the observation time was twice as long. So that's how. So you can see, you hit the right 3 keys, you'll get better growth. Let's take a look at the next one. Couple of sounds really running whole. And in this case, I pointed out the interpulse. You look at the middle. The one on the right of these two goes better. Well, let's see. Again, the one on the right has the better frequency range, so there's more data. And although maybe these two samples, they have the same integration, the one on the right also has a better observation time. So all the two on the right is the better. Into another inner pulse. This RA 627. Now we get it happened to be in the database a lot until what regardless. Well, so here we see somebody selected a very large range. That's good. They selected an integration time or you pull for improve it, but not a very long observation time. 60 seconds or so is kind of what they recommend on the site for a right pulsar. So I think it could have been connected also over there. Now there's an European pulsar database. I was trying to see it happened in the intervals. I know it's not some of them depending on mechanism. And I thought, well, I'm not gonna decide what that is. It just could be noise, even though it shows. Just didn't have it. Move on to A26, where we do have some comparisons. We've got 4 comparisons. Yeah, this one, 2 side by sides have similar frequency range. Both have the same frequency. Both have the same integration time. The only difference is that the one on the left has a longer observation time, and look how much better this the one on the left better observation. So the Pulsar RA exists. And here we have this one. The one on the right and longer range will have the same integration time, but the one on the left has a much larger observation time. So you put them all together and take the observation time going far, and you see that in the pulse. Now, some of these, you're not sucking any of your pulse. That may be the case. That maybe it's below the noise line and you're not seeing it. That's what I think is happening. So not every pulsar that is an inner pulse might not be visible on one ear, but certainly you can find some do inner pulse. So no, R 53. Both of these are breeds. They have the same frequency range, same integration time. The one on the left, which seems to be slightly better, has a better observation. And 2 more of the same pulsar. And full high better observe, better integration time. Better integration time, really the same observation time, predicted profile. And I compared that to the European pulsar newspaper. I remember it's perfect this that you used to hear. These lines have different functions. You read down here. R's for these pulsar that's old testing and then your circuit polarization or relation. I think this is just an any interpulse here. Now we have the RA 1705. Now, here's an interest. The fear was from here's one I said is RA 1705. And if you look at the actual RA declination, pretty close. They also have the same 3 P's, identical parameters, and they look so different. So something was, so that's when I started looking at all the other items on the pulses. And they're different periods. The pulsars are not going to change your periods. Obviously, there are 2 different pulsars, and that explains why you really have the 3 same P's. You have different graphs. They're not the same pulsar. They just happen to be very close to each other. Next one I thought was very interesting. Here's one where I think the blue point in an hour about. Really, I think that's the air pulse inherited to the European pulse, where that's my, you say it right, plus the names. I think. And Pulsar, 1932. Pulsar really good. But the one on the right has a slightly longer observation time, saying opposites. Pulsar RA 6. Let's go on. You got the same frequency range, same integration time, but the one on the right is 783 seconds observation time. The one on the left is 601 seconds. The one on the right is slightly better. So an extra 180 seconds made a difference there. As far as getting a clear profile. You don't always see the interface. Oh, we love the quick question where that your sister is. Let's go quickly through some of the others. So there's almost switching. I will Pulsar. I only found one of the 20 meter database. So I ran that as an a reference to paper that talked about it. So the parameters was not the best parameters, but as you can suggest some. There it is. I'm finding a bigger pulse. And switching pulsars. Here I run is another paper. This particular also has 5 components to it. And one of my observations, she's talking up for 20 years, possibly initials after the observations. We all share the same SARA. And I didn't do a very good job here. And I know what my mistake was. I selected a very long, very broad truth. Each asked my sample times. These did more than the recommended 60. But I did select the best integration time. So you can see here that is where is iteration times is the same. So we look at the sample time, it's 4 milliseconds. Otherwise, divided by 1,000 to get 4, but then I forgot to divide by another 100. So my sample time is too big. And if we go back to one of those earlier charts, the sound time is too large compared to the Pulsar period. You get a lot of peace. So that was the era. And if you select the lower iteration time, you don't need that. We'll present it. Unlike the past, some names, good reading. Here is in words for your reading. And there is something called a radio star. I was curious about one. So the paper is A or I is one of them. So what is my mistake? I made the same mistake. I took the sound, the integration here for milliseconds. Forgot to divide and need extra one. So that's why you're seeing these. Simulation of Pulsar. There was somebody in last year in presentation. Pulling about that for this presentation. Specification. Go for the plane meter. I left you some information on your Pulsar network because that would be useful when you're comparing your observation on Pulsar profiles to the European database, a little bit on the Australian network used for different purposes. Takes us to the end. So the thing I want you to get out of here is remember how this is to get through those 3 P's. Remember the frequency, range, for integration time, and for observation. And if you get them alkaline, you should be able to get any Pulsar profile. Interview. How can we see demos? Right. Make sure I'm all. So in the past, when we signed up, there was a restriction. You had to be a U.S. citizen. That's no longer the case. If you are not a U.S. citizen, you can still sign up to 20 meter, although you have to answer 6 questions. When you email you those 6 questions, and it's fairly simple. I get back to my Muslim travel, and now get an immediate response with you. Usually when it's over 2 months. And I think I have some time, so let's see if I can make the dish move. No. And once I get it set, those who haven't seen the dish move before, they can all watch it. It's in that direction. Now the closest radio telescope to this, with the next one after. And I'll stay in here. Those who remain here as well as folks online. If you got a question, we'll see if you answer. So let's go into web page. There it is. I'm loading bar up there, but that's single column and just so you can go to a page here, and then you're going to put in the SARA password. You need to see that password. Let's see. I'll invite you to see how did I use superstition you hustle pass. Creating your multi. Do you see that on the screen? We'll see there. The words go off. This I do it. You won't see the S. All right. Let's build a cast. Password circles. Half the times we've been doing this demo, half the times this doesn't move. It's easy to say it's down for maintenance, but usually it isn't. Usually it responds immediately. So when you're setting your initial parameters, like you are here, instead of radio observing, let's see. I want to get something that's way out in the sky, not by the sun, because if it's too low by the horizon, there's usually a parameter. Only observe when it's above a certain that we're reached, and only observe when it's a certain distance from the sun. So you've got to make sure we're not. Let's find. Yeah, I didn't use. That's what. Okay, what is up there? That might be a pulsar. I believe no one by name. Wonder if the crab pulsars was. And if it isn't, I'm just. Let's see if it can find. There it is. Oh, I think iron is there. See? So that's good. We're going to select that. And then let's see. Unfortunately, it's so close to this continent over there. So let's just to get this move. Let's try to get the minimum saturation. I think that looks like more than 1 degree there. And I think we're above 100 degrees, but let's just be sure. Let's put 10. And you got an 8 here, but because that's me, my initials down. So there we go. This should work. I think it's 1 degree from. And that right now we're at 6. So let's say continue. And this screen just happens to have the Pulsar mode here, which we want to use. Yeah, high resolution. So let's do this on spit on it. To do the Pulsar mode. And let's do the here it is. The before you do all, I've used too much off, so let's do the all. And we'll do the track. Right away. And right. The crab pulsar is fairly right. I did get away for 1 second with I mean it'll move regardless. And now, but since we want some time out there, everybody see it. They will want you to put 60 seconds in here. So let's iteration time. Oh, that's what we gotta do. I don't know that this is it's not gonna allow me. I think that's the small side. Let's just see what periods is on that. Let's try to get this. 001 001 with the right line by 100. That's what we want. Then I kind of do that from a few other.
Those T-shaped will let you do it.
Oh, in the
If you're turning ends,
okay, I see.
you do T-shaped 0.001.
All right, actually that worked. So I don't have to do that calculation. Well, actually, it's a larger. That seems too small. And that wasn't my observation. I don't see my ST. That was somebody else's, but it worked. And we see what I hold my own condition. You wanted to crowd. People were. There it is. Somebody, yeah. This one I had to. Yeah, I'm gonna go with this because I think that's the better one, just from memory. Doesn't matter. We keep it later. So then you get the list. It's the middle. And how do you know it's moving? Because this ray is going to say active. But to make sure it's active, you have to get off the page for a second. And then go back on the page. And it's still ready. So let's give it a couple more seconds. Still back on. And I hope it's not down. It's going to do anything for the pump. You're going outside. Please turn off. There is success. It is moving. Yes, it's active. Whoever wants to see the dish move, it's Chip watering monitoring for questions. Has at least half the level class leaves. Does anyone here in the classroom or online have some questions for me? I have a question. Then, how many hours are allocated for SARA? How many hours? The credits were. So the credits we buy these, and that's a big question because you can get your own account. The credits are affordable. I think for 5 hours, it's about $300. So that and you don't need a lot to do an observation. Depends on you. So yeah, it turns out to be about just over 10,000 purchases or cents. We usually get it on a 1 year basis, 6 months now. I think that has to do maybe with something on starter keys. Okay, so coming back to your presentation and observations for the double pulsars, I think the big one was yes, which is confidence. Somebody just not going to want to see you hire us. And then you care about some preparation work that wasn't so bright, needed more. So I did 60 seconds. I think things 1 meter stock 7, driving Pulsar 40 seconds, 60 seconds. Granite also very bright, so that's why I do. But it's something else they are. Which is why I always know that the rate is to see here at anybody that's success. I'm one of those there's 4 cents. We're sleeping. Well, 1 hour to come to the horse. I'm the worst. Dollars, and that's supposed to be over 10,000 seconds. Correct. We're local single observations. It's which I see what you know I could do it. Yes, you want to know what all would be in the range of $50 per observation. But that's another big one. Some people like radio names, and I've done it. And to do a raster scan, they consume a lot of time. Over half an hour. So there are things, because the fault on raster can make it a nice crisp image. It's preset. It costs a lot. There are things you can do. You can increase the gap space. Trims down. You 5 meters or raster. So if you're not, instead of going back and forth high definition, you got a big gap. Because the gap is so wide, you're actually seeing the antenna being main lobe as it comes through the target area. It's actually dragging some of this. I think there's the antenna school, that's part of the assumption. You'll see in there, Erastus, that pattern. I think that'll be a now pattern. But if you had a very high resolution, you wouldn't see that. It'd be a nice image. So anybody out there, be mindful of these awesome sounds. If you have something in mind where you know high resolution image, or you want something that's going to cost a large part of the budget, contact us. We'll probably say, well, you're doing this for a presentation that, we'll let you do that. Spend the money. Tell it what you found. You're doing a presentation for Inspire. We're pretty flexible. But, just don't eat up the budget on your own if you not know it much. You just experiment. I didn't even also experiment for the first time. Putting one step in for anything, you will get something out of that. And that will keep you trying to interpret, what did I get for that one? So I hate this. No matter where you point the radio telescope in the sky, no matter where, except the lofty wall, no matter where you go in the sky, you will get hydrogen peace. So whatever you thought you had in the target, said you want to observe bars, which is not going to see it in the 20 meter. But you will get a peak for bars. You're not seeing bars and see all the hydrogen. So got some learnings on how these radio telescopes work for better interpretations. Easy input things, you can't break it, but what you get out, maybe you would expect to be. You're not fully understanding what you're.
We paid from photographs to musician back to back. At the time we paid for, or is it created for the next edition? So
It's supposed to be the observation time. That's what they charge for observation time. So it was second, but you charge 1 second. However, what I've noticed, you see the results. Even if you took 1 second, sometimes it shows like a 10-second number. I'm not sure what it's doing there. Could be calibrating something, but that hasn't been charged. At least that's kind of what I remember. Even if it's a small number, it tends sometimes it'll be a little higher once. But it'll be charged for what we request. It's 1 second, 1 second, or it's 60 seconds, 60 seconds. What does time really mean? I mean, is that like a stacking stuff like we do? And so the observation time is, and it's better, well, it's the actual time that the radio telescope antenna is on there tracking our. So if you got in a track mode like this was, it's tracking it for the 60 seconds and then going back to bird. But is that a bunch of sweeps that are then being, well, that's the track. If you're doing a radio raster scan, it's got a swing back and forth. You can go left, right, or up and down. There is a difference when you do that. Like you're doing up and down, you're getting some round effects. But that's where that. And if you can cut down that sweep time, like showing the different gaps, and have eyewitness. So maybe I'm going to do that real quick. I won't put the observation in, but I'm going to.
Can I ask a quick question from online, please?
yeah,
Yeah. When you're doing the pulsar observations, my understanding is the 20 meter has the two receivers and the two polarities, the X and Y outputs. And so when doing the pulsar's observations, which one of those receivers is the one that's activated, or do you have a choice?
Yeah. Well, I know for some observations, say if you were selecting the hydrogen one or the hydrogen band, it's going to ask you what your primary antenna and your secondary antenna is. Now, as we just did this, it didn't give me that choice. But let's go back because I think if you did a higher resolution, you have a choice. So let's see if that is the case. So let's put Pulsar back in here. Yeah, I'm not going to do this observation. I'm going to take you through some steps. Pulsar. I got to put my initials there because we're not going to say it. So we have a run low resolution. You have our choice with the center frequency. If you want the high resolution, you do have a choice. You have your center frequency and your secondary frequency. And even if it wasn't pulsar mode, well, you only have pulsar mode and low resolution. So to answer your questions, you don't have a choice. But if you go to high resolution, you do have a choice, but you don't have the pulsar mode anymore. So that's how it's set up.
So if you set up integration time, that's you have to do that based on what you're wanting to find, I guess, because you set the integration time up within the program.
Yes, in the case of the Pulsar, it's very important for the integration. For other objects, it's important too because you're going to get a better quality. But so here you can select. This is where you're going to select your integration. I think we had the same box. We did the Pulsar. So you have to have some idea of what your integration time should be, but it's more crude for the pulsar observation to get it right. Integration time, which a lot of sweet keys are important because it relates to the pulsar mode. Then that answer.
Well, back to Adrian's question, wouldn't you get the data for both polarization antennas?
Yes, if you should, which is why I have some information on there. Let's go into here. Not off the top of my head. Let's see. You're going to see the observation. So my 3Ps weren't so good. I kind of did this in a rush, and this is what I got. It's kind of noisy. Maybe I should have had I could have had a longer observation time. I think my integration time is okay, and the frequency range I had, so I could clean these up more. This is this is the Pulsar. So usually now, let's take a look at trying to find where the data is. I think this is just going to give you this observation data. I think that it'll be used. How about let me just all right. Unlike other observations, trying to remember what Skip told me. I don't know if he's Skip here.
He's going over to the same.
Yeah. Okay. So because collecting data on the pulsars really fills up the storage, they're not displaying the raw data here. There's a way to get that raw data by requesting that from hours. It does take some time to get, and it's be mindful of this time, but it is possible to get that. So I don't see anything up here that lets you get that. I think that's the reason why it's just too long. You must click here. Now, if this was another type of observation, well, here, let's see. Let's I mean, these will simply on the internet. Just long place. See this. There's a lot of all the observations, whether it's SARA or other groups. And you can see the one I just did on the latest one here. But let's not find something else that's not a pulsar, just for the those in the audience who might not. Yeah, this is the first time. We'll just get Sigma A, Sigma A. Here's a raster scan. That's why I mean with you see the patterns of going back and forth with the raster scan. But you should see the data here. You have this data, you have the two antennas. You have the time, so for everything except pulsars, it's put here, but there's a way to request the raw pulsar. A bit time consuming, but if you have a good need, still help you out. Does that answer your question?
Well, no, it didn't, because the question originally was which of the two polarizations is selected for pulsar, or where does it show that? And so that was the original question.
Well, you remember when we selected the pulsar model at low frequency, it already automatically selected the super frequency, which was, I think, 50-53, example we did. Let's go back.
So, like in this observation, so you see both X and Y polarizations, and it displays that. So, but you don't get that information on the pulsar, so it's indeterminate as to which one of the two is being used. And that was the original question: is there any way to determine that, or does it combine both? I don't know. That's kind of my question.
I think I'm trying to hit the back up. It's not letting me do that. So let me just in this defense. Here's the observation I just did. The input, here's your center frequency, 1550, which was automatically inputted in there. I'm assuming that's the frequency and polarization that's being used. If it was a regular observation, you see the two. I see what you mean. There'll be two in a regular plot. There'll be two frequencies: the center frequency, and the secondary. And each of those plots would have the two polarizations there. Or this particular frequency, which one is being used? And I don't know the answer to that question.
Okay, that's just what I wanted to know. I guess it's indeterminate.
Now you might get some clues if you request the raw data from Skip, and Skip is pretty good at this. He might know the answer. So as you're asking, can I get raw data for a pulsar? And maybe he may have some, needed for a particular pulsar. He just want to look at some raw data. He may have some that he can provide to his studios, and well, he may know the answer to that because he does do a lot of work on.
It sounds like that in the background, their software is doing some interpretation of those two antennas, but you have all that raw data. But to determine the polarization, you'd have to calculate it from the raw data of the two antennas, the vertical and the horizontal.
Yeah, obviously because it's not displayed on. Continue around. It's
Another comment, Steve, when you first started, you had to keep toggling back and forth until you saw it was active. You think the telescope was moving from bird bath over to its target, and then once it reached its target, it would become active?
Well, usually when I do that, it becomes active fairly quick. And although I had to toggle a couple times, it didn't take too long for it to be on. As far as the display to active, I don't know when it happens as it corresponds to burn bath or the actual observation. But you can see those now. Well, you didn't have to wait too long for it to become active. I'm glad it became active because if it was down for piece, might wait a couple days for it.
Okay.
But it's usually put an observation. Get it instantly, or if it's an observation that's not written with them up, it'll tell you how many hours from now before it is.
How far will that do go? I mean, if you put something in queue and it's like, this is down for a week, will it keep it that long?
I think so. I've had days before the operators there for some. I think observations of Jupiter stars are seeing I had them. No, you can't. I was just experimenting. I was curious about. But it wouldn't execute on Jupiter, even though it was in the sky. And I think that must be because it was just too close to the sun. So I was staying here a long time. Now I know distance from this separation. At some point, you gotta be knowledgeable where your object is in the sky, might use, might not, and how it relates to when you select minimum elevation versus suns. Wonderful.
Thank you very much.